One of the universe's most enigmatic phenomena is the black hole. Welcome back to the channel. Today we'll talk about what a black hole is and how it originates. Don't be misled by the name. A black hole is anything but a void. Instead, there is a lot of matter crammed into a little space. Imagine a star 10 times more massive than the sun being packed into a sphere the size of New York City. One star's end is a black hole's beginning. Most black holes are created from the remains of a massive star that explodes in a supernova. Smaller stars decay into dense neutron stars, which are insufficiently massive to trap light. Subramanian Chandrasekhar, a 19-year-old scientist, was contemplating the implications of several recent findings, including Einstein's theory of special relativity when he had his first insight into black holes. According to his calculations, all stars with masses greater than 1.4 times that of the Sun will eventually exhaust their fuel and disintegrate. The existence of black holes was quickly discovered to be necessary by other laws like Einstein's theory of general relativity. The concept gained popularity over time. Eminent theoretical scientists investigated the specifics of the mathematics and physics underlying black holes in the latter half of the 20th century, including Stephen Hawking at Cambridge, John Wheeler and Jacob Bekenstein at Princeton, Chandrasekhar and Robert Wald at the University of Chicago, and many more. In the meantime, evidence from telescopes started to mount that black holes existed in the cosmos. These stellar mass black holes, which are scattered throughout the universe, are typically 10 to 24 times as massive as the Sun. When another star gets close enough for some of the matter surrounding it to be snared by the black hole's gravity and produce X-rays as a result, astronomers can see them. A chain reaction of collisions between stars in dense star cluster could result in the accumulation of supermassive stars, which would eventually collapse to generate intermediate mass black holes. This scenario could explain how supermassive black holes are formed. A supermassive black hole is created when two intermediate mass black holes collide at the galaxy center, where the stars cluster. There may be additional ways for black holes to originate besides the ones that scientists are aware of. An enormous star collapsing after its life is one method for creating a black hole. The theory that a large star will collapse when it is burned through all of its fuel was first calculated by Professor Subramanian Chandrasekhar. At first, the theory was mocked, but later, other scientists concluded that the star would continue to plummet inward forever, eventually reaching its center and generating what is known as a black hole. As they consume gas, stars, planets, and even other black holes over time, black holes can become more enormous. But by observing how they affect neighboring matter, we may deduce the existence of black holes and study them. A black hole will accrete matter or pull it inward if it passes through a cloud of interstellar matter, for instance. A typical star may experience a similar behavior as it approaches a black hole. In this situation, when the star is being drawn towards the black hole, it may rip apart. The heated and accelerated attracting matter radiates X-rays into space as it accelerates and warms up. Recent findings provide some enticing evidence that black holes have a significant impact on local communities. Theoretically, it can be demonstrated that no force can prevent a star from collapsing under the pull of gravity if the total mass of the star is high enough, about 3 times the mass of the Sun. But an odd thing happens as the star disintegrates. Time on the star slows down in comparison to time kept by observers far away when the star's surface approaches an idealized surface known as the event horizon. Time halts when the surface hits the event horizon, and the stellar collisions have the potential to produce much larger black holes. Gamma-ray bursts, which are strong, brief flashes of light, were observed by NASA's Swift telescope soon after its launch in December 2004. A supermassive black hole is a different kind of black hole. It is still unknown how they arise. They are far too enormous to have been produced by one star collapsing. Black holes can consume other black holes, therefore it's conceivable that supermassive ones are constructed from a merger of several smaller black holes. Professor Holtz speculated, or possibly these large black holes were very ravenous and ate so much of their surroundings that they swelled to huge dimensions. But because we can see that these supermassive black holes were created very early in the history of the universe, possibly too early for them to have been created by stars that had reached the point of collapse. Possible it's that there are still other ways to create black holes that we are unaware of. Supermassive black holes and star-sized black holes are the two types of black holes. Supermassive black holes get their name from the fact that they have millions to billions of times the mass of the Sun. A supermassive black hole like this one is located like a seed at the heart of almost every galaxy in the cosmos. Additionally, they are correlated. A smaller galaxy has a smaller black hole and a larger galaxy has a bigger black hole. Scientists believe these supermassive black holes had something to do with how galaxies develop as a result of all of this. But the nature of that connection and how the supermassive black holes first came to be are still unknown. The supermassive black hole at the center of our own Milky Way galaxy is known as Sagittarius A star. It is approximately 15 million miles across and has a mass of 4 million suns. It's too far away to endanger Earth, so don't be alarmed. Astronomers concluded that massive explosions can be caused when a black hole and a neutron star meet, creating another black hole after Chandra and NASA's Hubble Space Telescope collected data from the event's afterglow. Giants and infants, black holes' basic formation process is well understood, but their apparent existence in two dramatically different size ranges has long been an enigma to astronomers. Numerous black holes, which are the remains of huge stars, can be found on one end of the spectrum, but the majority of star black holes are incredibly hard to find. However, based on the number of stars big enough to create these black holes, scientists predict that it no longer has been thought by astronomers that there are no mid-sized black holes. On other hand, current data from Chandra, XMM Newton, and Hubble support the existence of mid-sized black holes. According to scientists, black holes will ultimately erupt, but it will take a lot longer than the universe has existed already. What will it resemble when that occurs? Another significant mystery is that. What occurs within a black hole? The frightening part is that we might never know, because we really don't know. That's all for today. What do you think? Let us know your thoughts about the black hole's existence in the comment section down below. Until next time, thanks for watching.